Good morning everyone, my name's Darren and I'm the Queensland Sales Rep at Island Technology, and welcome to this webinar. This is part 3 of our 4-part DrayTek VPN solution series, and today we'll be looking at VPN Load Balance. So today I'll start out by giving you an overview of what VPN Load Balance is, how it works and what the benefits are. Then we'll have a bit of a look at the configuration options in both Linux and DrayOS routers. So first let's look at what VPN Load Balancing is. VPN load balancing is basically combining two VPN tunnels over two different WANs to behave as if they were one. In this diagram, let's assume the head office on the left has two internet connections, say for argument's sake Telstra and Optus ADSL. The branch office on the right also has two, let's say TPG and Dodo ADSL. So we've gone ahead and established two VPNs between the two sites over two different WANs. VPN load balance allows us to combine those two VPNs into one VPN trunk. There's two advantages in doing this. The first is redundancy. If any of those four WANs drops out and one of our VPNs is lost, all of the traffic will automatically switch to the other. The second is bandwidth. We've now got all of our VPN traffic shared over two VPNs over two different WAN links instead of just one. So basically running two VPNs over two WANs increases our link capacity compared to running a single VPN over a single WAN link. Current routers that support VPN load balance are basically all DrayTek routers with two or more WAN ports which can operate simultaneously. That is the VIGA 2862 series, the VIGA 2926 series, the VIGA 2952 series, the VIGA 2960, the VIGA 3220 series and the VIGA 3900. On to a look at configuration. So basically what we need to do is combine our two VPNs into one VPN trunk and also allow communication between them, but also allow that communication to switch to one or the other if one of our VPNs drops out. The magic that makes the communication part possible is the GRE protocol, which we've mentioned a couple of times in previous webinars. GRE stands for Generic Routing Encapsulation and was developed by Cisco way back in 1994. It allows the movement of data from one private network to another private network over a public network through a process called encapsulation. One issue with GRE though is that it's not a secure protocol. To get around that, we use it with IPsec to encrypt our data. To set up GRE, we basically have to allocate an IP address to it on each interface of our VPN tunnels. For the 3900 at head office in this diagram, we've assigned 10001 to GRE on WAN 1. For WAN 2, we've assigned IP address 10003. The same has to be done at the branch office at the other end. In this case, we've assigned 10002 for our GRE on WAN 1 and 10004 to WAN 2. So what we have at the end of that is kind of a virtual LAN using the 100x IP address pool for GRE to use to communicate. Incidentally, don't get thrown off by the Class A addresses on the WANs in this diagram. This is an example we use in our workshop where we set up an artificial internal ISP we can use for our VPNs. In the real world, we'd see public IP addresses on our WANs. Where do we find our GRE settings? In DrayOS routers, we enable GRE and assign our GRE IP address pool in the LAN-to-LAN profile under VPN and remote access. In Linux-based routers, there's a separate tab in the VPN profile configuration menu. The remaining thing we need to do is combine our two VPNs into one VPN trunk. This is done at the dial-out or client end in DrayOS routers. The setting can be found under VPN and remote access, VPN trunk management, then go to General Setup down the bottom of the page. Then it's simply a matter of enabling it, giving it a profile name, and then selecting the two dial-out VPN profiles from the pull-down lists. In Linux routers, the VPN pool and trunk is also created at the server end, because in the case of Linux, either end can initiate the connection. In DrayOS routers though, we can specify dial-in or dial-out for our IPsec tunnels, and we set up our trunk at the dial-out end. That's pretty foolproof too if you don't remember that. If you try to create the trunk at the dial-in end, you won't find the VPN profiles listed in the member pull-down list, and it specifically asks for a dial-out profile as well. So to recap, two or more LAN-to-LAN VPN tunnels between sites can be established using two or more WAN connections, which can be from different ISPs. VPN load balancing provides high availability, increased performance and scalability, and redundancy if one of our WAN connections fails. Traffic over each VPN tunnel is transmitted according to real-time bandwidth. If we drop one of our VPN tunnels, we don't lose our TCP session and everything continues on as if nothing happened, just slower. GRE is a Cisco proprietary tunneling protocol and is not secure. And GRE supports any layer 3 protocol and is used to send data back and forth between two private networks over a public network. So that's about it. Now we have time for a few questions if anyone has anything they'd like to ask. Here's a couple. Can a single WAN router be used for VPN load balancing? No, we need a minimum of 2 WAN connections, 1 VPN tunnel for each WAN. Where do we configure VPN trunk management? VPN trunk management is always configured in the VPN clients, that is the dial out on DrayOS routers. However, when a Vigor 3900 or other Linux-based router is used at the server end, the VPN pool and trunk also needs to be configured at the server end. That's only for Linux routers though, because either end can initiate the connection. On DrayOS routers, we only configure it at the client end. Can I use the same IKE pre-shared key on both VPNs? No, make them different. It'll work okay at first, but if they're the same and one of your WANs drops out, an incoming VPN won't know which profile to use, so you end up having 2 incoming VPN tunnels trying to connect to the one profile, meaning one VPN tunnel won't come up or the VPN tunnels will drop. I tried this out in a test environment, and even though one VPN appeared to be connected, I was seeing lots of packet loss and general chaos, which sometimes continued on even after the second WAN came back online. This didn't happen if I used different pre-shared keys on my 2 VPNs though. In that case, when I disconnected one of the WANs, I'd see a couple of pings drop out and then it would happily ping away again. Same again when I reconnected the dropped out WAN. So that's it. Thanks for taking part today, and we hope to catch up with you again soon. And bye for now.